Hi, I'm Rob, and I'd like to welcome you to this video on NumPy in the Python for Data Science and Machine Learning playlist on the Cumulus Cycles channel. Before we get started, I want to mention that this video assumes you have some exposure to working with Python. If you're new to Python or need a refresher, I recommend watching the prior video in the playlist where we reviewed some fundamental Python concepts before moving forward. Okay, with that out of the way, let's get started with NumPy. NumPy is a numerical Python package commonly used in scientific computing. It provides multi-dimensional array objects and methods which perform operations on arrays, including mathematical, logical, shape manipulation, sorting, and more. To install NumPy on your system, you can use the pip install numpy command. Then execute the pip show numpy command to verify the installation. Now, with NumPy installed, let's take a look at some code. To get started, I'll go ahead and run this code in Jupyter Notebook to install NumPy. Then I've defined a function, display array details, which takes an array as a parameter, then displays the array type, dimensions, and shape. Now let's use NumPy to create a one-dimensional array, passing it a list of integers. Here we see in the output that this is a NumPy array. It's a one-dimensional array, and it has a shape of 5 because there are 5 elements in the one-dimensional array. And looping through those elements using the NumPy iterator, we see the individual values. Now, creating a multi-dimensional array in NumPy is similar, where we call the array method on NumPy. We're passing an outer list with 2 elements, the first being a list with 3 elements, and the second being another list with 3 elements. Here's another view of this list. So as we did before, we'll print the array details and the contents, and then traverse the array, printing the individual values. So as before, we see it's a NumPy array, it's 2-dimensional, and it has a shape of 2, 3. Because remember, we passed the outer list with 2 lists, so here's array element 0 and array element 1, each of which have 3 elements, hence the shape 2, 3. Here's the contents of the array, and traversing the array, we see the individual values. For a 3-dimensional array, we're passing 2 lists, which both contain 2 lists, which all have 3 elements. So let's execute the code in this cell. We see our array has 3 dimensions, and its shape is 2, 2, 3. For the 2 elements we passed in as the outer list, and then internally, each element has 2 with the 3 elements. Array slicing is an important skill to have when working with NumPy arrays. It lets us extract data from the array for the particular elements we're interested in. So here, I'll create a one-dimensional NumPy array of random integers between 1 and 100 with a size of 100 elements. So let's go ahead and run the code in the cell, and we'll take a look at the output. So our one-dimensional NumPy array has 100 elements. Here's the original array, and then a sorted array, which I got by calling the sort method on NumPy, passing the array. If I want to get the first 10 elements in the sorted array, I'll pass :10, which says start at the 0th element and go up to the 9th. And in the output, we see the first 10 elements from the sorted array. If I want to get the last 10 elements, I'll start at -10 and go to the end. And in the output, we see the last 10 elements, which are here. If we want to get every 5th element, we'll use :5, which says start at the beginning, go to the end for every 5th element, which we see here. And finally, here we're getting elements 25 through 50, which we see in the output. So that's slicing a single-dimensional array. Now let's create another multi-dimensional array, execute the code, and scroll up and look at the output. So here we see we have a 2-dimensional array with shape of 3, 3, as we have 3 lists with 3 elements each. Looping through the array, we see our elements and their values. If I want to get the first 2 elements in the array, I'll use the index 0:2, which if we look at the output, we see here's the 0th element, which is 0, 1, and 2, and the second element, which is 3, 4, and 5, and that's at index 1. Array 1: will give us the array indexes starting at 1 and going to the end, which is 2. So if we look at the output for array 1 colon, we see 3, 4, and 5, which is at array index 1, and then 6, 7, 8, which is at array index 2. Passing array 0 colon 1 comma 0 says start at the 0th element, go to 1, which will only give us the 0th element because the 1 is excluded, and grab the value at the 0th index. So if we look at the 0th element and the 0th index in that element, we see 0. So looking at that output of 0 colon 1 comma 0, we see the value 0. If we pass 0 colon 2 comma 1, this will give us elements at index 0 and 1, and the values in index position 1. So elements 0 and 1 with values in index position 1 will give us the values 1 and 4, which we see in the output. And array 0 colon 3 4 2 will give us 0, 1, and 2 with the values in the third position, which will give us 2, 5, and 8. If we just want to grab the first element in array index 1, we pass array 1 comma 1 and we'll get 4, where here's the first index with element 0 and element 1. And finally array 2 comma 2, so 2 comma 0, 1, 2 will give us 8. Now let's work with some random numbers in NumPy. Here I've created a random numbers list and set min and max indexes for the range. So we have a for loop for I in the range of 1 to 100. Use NumPy to randomly generate random integers from 0 to 25. Then append those values to the random numbers list. Then I'll use NumPy to sort the list and then print the sorted numbers. This loop is similar with the exception that the random integers I'm generating are between 25 and 50. So let's go ahead and run the code in a cell and take a look at the output. So here we see the first list with sorted numbers between 0 and 25, and the second list with numbers between 25 and 50. Now, what I want to do is use NumPy to create an array from the list of numbers. Then I'll pass that array to the display array details function and scroll down, and we see the results. So now we have a list that's been converted to a NumPy array. It's a one-dimensional array, and it has 100 elements, which we see here. Now I'm going to take that one-dimensional array with 100 elements and I'm going to call reshape on the array, creating a two-dimensional array with 50 values in each element. So if we scroll down, here we see our two-dimensional array with 50 values in each element. Then I'll reshape it again to 425, which if we scroll down, we see the two-dimensional array now has the shape of 4, 5. So there's 4 elements with 25 values each. Now I'll create a new NumPy array with random integers from 25 to 50 with a size of 3, 3, which will give us 3 rows and 3 columns. So if we scroll down, we see the results here. Then I'll take the random numbers array and call ravel on it, which will convert the multi-dimensional array to a one-dimensional array, which if we scroll down again, we'll see our one-dimensional array, which was created from this multi-dimensional array. Finally, what I want to do is generate a random distribution by calling rand and passing 10, which will give us 10 random floats between 0 and 1. And then we'll display those details. So let's run the cell. And here we see our one-dimensional array with a shape of 10 and the values ranging between 0 and 1. In this final example, we'll use the randn method passing 3, 3 to create a standard normal distribution. And we see the results. So that's it for this notebook. So let's go ahead and close it and open up the next notebook where we'll look at mean, median, and mode. Now, before we take a look at the code in this notebook to compute mean, median, mode, I just want to jump over to my GitHub repo for a second and go into the Python for data science and machine learning repo, and then into 2 statistical thinking. And this README will give you an overview of statistical thinking in data science, where we cover some key concepts, talk about data and data types, and take a high-level view of some of the common topics in machine learning and data science. Now, if you want to take a deeper dive into these concepts than what we'll be looking at in the next notebook, feel free to take a look at this README. And inside of the folder, you'll also see a demo IPYNB file, which is used to calculate the plots that are displayed in the README file. But for now, let's jump back into the mean, median, and mode notebook. Okay, to get started, of course, I'll import NumPy, and I'll also import stats from the SciPy package. To display the plots on this page, we'll be using matplotlib and Seaborn. So if you haven't done so, make sure you install those packages. Now I'll go ahead and run this cell, and then we can take a look at the code for mean and median. Now to get started, I'll use NumPy to generate 25 random integers between 65 and 100. I'll store those in a variable grades and then print the type and the grades themselves. Then I'll use NumPy to find the mean, or the average, of the grades. Then I'll use NumPy to sort the grades and then find the median of the sorted grades, which is the middle value in the data set. So let's go ahead and run the code in this cell. And we see that in our NumPy array, we have a list of grades with a mean, or average, of 83.72, and the median, or middle value, is 82. To find the mode, or the most frequently occurring value in the data sets, we'll use the stat package and pass the grades. This will give us an object back where we could reference the mode property of the object. And we see the mode, or most frequently occurring value in the data set, is 76. Finally, let's use NumPy to create a random normal distribution of 1,000 salaries with a mean of 25,000 and a standard deviation of 15,000. Then we'll use NumPy to find the mean and median and print the values to 2 decimal places. So here we see our NumPy array has 1,000 salaries. The mean is 24,267 with a median of 24,376. And now let's show a plot of these values, where we see the median is around 24,3. All right, so moving right along, we'll close this notebook and open 3_math. So again, we'll import NumPy. I have the display array details function, and now we'll perform some addition and subtraction on NumPy arrays. So to get started, I've created a list with the values 1, 3, and 5. I'll use NumPy to convert the list into array 1, and then I have list 2 with 2, 4, and 6, which again we'll use NumPy to convert the list into an array, and then have a variable array 3 where we'll simply add array 1 and array 2. And for array 4, we'll subtract array 1 from array 2. So let's go ahead and run the code in the cell. And here we see NumPy array 1, which is a one-dimensional array with a shape of 3 with the values 1, 3, and 5. Array 2 has a similar dimension and shape with the values 2, 4, and 6. So for array 3, I calculated the sum of the 2 arrays. So if we look at the values, we'll see that the value at element position 0 is 3, which is the sum of array 1 element 0 and array 2 element 0. Next, if we take the value at array 1 element 1 and array 2 element 1, we'll get 7. And of course, the last values are 11. Array 4 was calculated by taking array 2 and subtracting the values in array 1, where we see the result of 1, 1, and 1. And just like with addition and subtraction, we could do multiplication and division on NumPy arrays. So let's just run the code in this cell. We see array 1 is 4, 9, and 16. Array 2 is 2, 3, and 4. If we multiply those, of course, 4 times 2 is 8, 9 times 3 is 27, and 16 and 4 is 64. Doing the division, we get the values 2, 3, and 4. Finally, let's take a look at some universal functions in NumPy. Here, I'll pass the value 4 to the NumPy square root universal function, which if we run this, of course, we'll see the square root of 4 is 2. And then I have a NumPy array with the values 4, 9, and 16, which we'll call square root on the array, which gives us the square roots of 4, 9, and 16 are 2, 3, and 4. And finally, in this cell, we'll raise 4 to the power of 2, which is 16, create a NumPy array with 2, 3, and 4, pass the array and the power of 2 to the power method in NumPy, and we'll see that the powers of 2, 3, and 4 are 4, 9, and 16. And pass array 2 to the exponential method in NumPy, and we see our output. All right, so let's close this notebook and open NumPy data types. So here we see that NumPy supports a variety of data types for its arrays. Some of the common data types are integer, Boolean, unsigned integer, float, and so on. So let's go ahead and import NumPy and then create a utility function for displaying the array element types and the utility function for displaying the array details. And then we'll create a list of names. I'll print the type of the variable and then each item in the names list. Then what I'll do is I'll take the names list and use NumPy to convert that into an array and display the array details. So let's go ahead and run this. And here we see our simple list where each value in the list is of the Python class string. Then when we convert it to a NumPy array, we see that the values are NumPy string data types. Here I'll create another NumPy array, this time passing the same strings in the list and set its data type to string. If you look at the results here, we'll see that these values are data type of NumPy bytes. So the difference is when we pass the standard list in and convert it to a NumPy array, we get a Unicode string with a max of 3 characters, because that's the length of the data that we passed in. Here, when we create the array and set the data type to string, we get a byte string of max 3 characters per element in the array. And finally, in this example, we'll create an array passing integers specifying a data type of integer 32. And if we look at the results, we see the numbers 1 through 5 are NumPy int 32s. Then for the final examples in this notebook, I'll create an array with floating point values and print the details. Then I'll take the array, call asType, passing an I to convert them to integers and display the results again. So here we see our initial array has a data type of NumPy float 64, which have then been converted to NumPy int 32. Okay, so we have one more notebook to look at, which will show us how to load data from a local CSV file. All right, to get started, I'll import NumPy as usual and create our function to display array element type and display array details. Now in this next cell, I'm creating a variable named student data, which will be populated by calling the load text method on NumPy and passing it the name of the CSV file, which in this case is student CSV, that I want to load the data from. The delimiter in the CSV will be the comma. Skip rows is equal to 1 because I want to skip the heading, and the data type is string. So before we execute this, let's go ahead and take a look at the CSV file. So as you can see, this is a simple CSV with 3 rows and headings. Now back in the notebook, we'll go ahead and run the code in the cell, and we see that data has been loaded into a NumPy array. It's 2-dimensional with a shape of 3, 6, where the first element is a NumPy array containing the data from the first row in the spreadsheet, and the same for the second and third rows. Now I'll create a Python class named person and a Python class named student, which is a subclass of person. Now what I'm going to do is create a new variable named students, which is a NumPy array of student objects. So for each row in student data, I'll instantiate a new instance of a student object passing the data from the current row in the student data, and then display the students. So let's go ahead and execute this. And here we see our NumPy array is 1-dimensional with a shape of 3, and each element is of the student type. Then finally, what I'll do is loop through the students, and for each student, I'll display some student data. If you'd like to take a deeper dive on the person and student classes, I recommend watching the Python Fundamentals video in this playlist. So that concludes this video on NumPy. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.